A very good morning to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for the webinar series on smart and sustainable manufacturing solutions, organized under the aegis of Industry 4.0 Expert Committee of the Chamber, jointly with Maxbyte. The Industry 4.0 Expert Committee is chaired by Mr. A.N. Chandramouli, who is the past president of the Chamber. Welcome, sir, for the session. Co-chaired by Mr. Jagannath, who is the COO of M2 Next, BFW subsidiary. We thank the entire team of Maxbyte, Mr. Senthil Prabhu, Mr. Ishwaran, Mr. Selvin, for facilitating and structuring this webinar series. The Chamber acknowledges the support of our annual sponsors for their immense support in the activities of the Chamber. Now I will request Mr. A.N. Chandramouli, the chairman of the Industry 4.0 Expert Committee, to take it over from here. Over to you, sir.
Welcome, Mr. Senthil Prabhu. I think Dr. Senthil Prabhu has a wide industrial experience. And welcome, sir, to carry out the first of its series of Industry 4.0.
Good morning,
there will be
sir.
at least six sessions going on in the next 6 months and maybe beyond also. And we have many topics to share. Yeah, I think there is probably an issue at the BCIC internet also. So what I'll do, without much ado, I will just give some few remarks about the background, why we are doing the series of Industry 4.0 program. Industry 4.0, has been now almost like a cliche. It's no more it's not even a buzzword, it's a cliche. And many organizations are still sitting on the fence whether we should implement it or not. I think the easiest way to visualize Industry 4.0 is to visualize our social programs like the Ola and the Zomato and the way we make digital payments. So if we can implement these concepts in manufacturing sector, I think the benefits of Industry 4.0 will be easily achieved. And then there'll be a big motivation to the industry. Coming to today's topic, Dr. Senthil Prabhu is going to talk about Lean 4.0. You all know that Lean, am I audible? I'm just wondering whether I'm audible.
Yes, sir, audible.
Okay, Senthil. Lean is simply put, it is waste elimination. Lean means different things to different people, but to me, it's just a simple one word. It's an elimination of waste. As the Japanese call it as the elimination of muda. The muda, mura, muri trilogy. The muda is the most important thing, waste elimination. In the Indian context, waste elimination becomes extremely important. The waste could be in the form of defects. We call it the cost of quality. There are many waste caused by rejections and scrap, etc., caused by quality problems, defects, and waste from a product or service failure to meet the customer expectations. It includes even warranty problems. And the second major concept in the waste elimination is overproduction. From making more product than the customer's demand. Customer wants 100 numbers, we produce 110, thinking we can keep a buffer. That additional 10 is a overproduction. Another way of looking at overproduction is customer wants model A 10 numbers and model B 5 numbers. But you ended up producing model A 12 numbers and model B 3 numbers. The total may be achieved 15 numbers, but model B demand is not met. So overproduction could be in terms of the total, or it could be even particular models. The third waste to be eliminated is waiting time. Waste from time spent waiting for the next process step to occur, right? The man could be waiting, the machine could be waiting, materials could be waiting, the man, machine, materials, all three could be waiting for the next process. in the production system. That's a waste. The fourth waste is a transportation. You are moving products within the factory or across shop floors or even across factories in some cases. And how to minimize the transportation. Wasted time, resources, cost when unnecessarily moving products and materials. There is a minimum movement anyway required, but that can be minimized. And any movement beyond the minimum movement, we would like to call it as a waste in transportation. The fifth one or the sixth one is a inventory waste resulting from excess production and materials which are blocking space, blocking money, right? This inventory is of no use. In the single piece flow concept of lean, even if you have one piece to produce the next product, it's good enough. You don't need 10 more pieces in the inventory in order to produce one piece, right? One at a time, one after another is ultimate concept of single piece flow in lean manufacturing. Again, it's eliminating the waste called inventory. Then there is a waste of motion, wasted time, effort related to unnecessary movements of people. Even within one workstation, people may be not able to access their raw materials while doing the machining or while doing assembly. How to minimize the motion within one workstation, right? The age-old concepts of industrial engineering will come into play in the concept of minimizing or eliminating motion within a workstation. And of course, unused talent, wrong skills are deployed in the wrong operations, or incorrect, unauthorized skills are being used, or there could be excess talent and they are sitting on the bench, as we call it in the IT industry. So many reasons why unused talent could be there in a production system, right? This is a seventh waste. The eighth one is the most important, is extra processing. If you can achieve a product by giving the minimum value addition required by the customer, any other activity which is added to the product is called the non-value adding activity. And the non-value adding activities are nothing but extra processing, waste related to more work or higher quality than that is required, right? It can be, you may be producing quality which is beyond the standards defined by the customer. And you may be delighting the customer, of course, but then some aspects may not be even appreciated by him. So therefore, these are all the extra processing waste. So basically, when elimination of waste happens, you achieve what is called lean manufacturing. To summarize all these things, what are the three major principles of lean? Shortening the lead time. That means in a process, when you are making some product over, let us say, it takes 3 days, can you make it the same product within 30 minutes, right? There are concepts of response ratio, where people have done research over the last 30 years. The response ratio being the total lead time of producing a product divided by the cycle time to produce one product, right? If a total lead time is 3 days and the cycle time to produce one product is 30 minutes, then the ratio between 3 days divided by 30 minutes, which is basically 144, 72 hours divided by half an hour, 144 is basically a kind of a ratio which reflects that the lead time has got so much scope to reduce. The ideal lead time being 1. If the lead time divided by cycle time is 1:1, then we achieved what is called the ideal lead time. So the response ratio 144 in this case example has got a potential to reduce 144 times. So shortening the lead time is a major objective of lean. Minimizing the cost in form of eliminating the waste, the various waste we already mentioned, is again objective of the lean. And with all these things, we still have to achieve the highest attainable quality. And quality is conformance to customers' requirements. Quality doesn't mean, looking good or functionality, etc. It means conformance to customers' requirement. So the 3-in-1 philosophy of TQM, TPM, and just-in-time concepts. TQM concepts address the quality, TPM concepts address the cost, and just-in-time concepts address the shortening of the lead time. But beyond all these three things, today we are talking about Lean 4.0, which means we need to have one more objective or few more objectives to be fulfilled through the digital technology. We don't need digital technology unless there are more objectives to be fulfilled, which conventional lean could not fulfill. For example, the flexibility of producing variety of products, the flexibility of producing customized products, the flexibility of producing fluctuating production demands, or flexibility when there is a supply chain fluctuation. So there could be an uncertainty in demand, uncertainty in supply, uncertainty in the models that is required, uncertainty in the customer's special requirements, right? Customization, as we call it, and so on and so forth. So a variety of products, customized products, fluctuating production demands, are few examples where high levels of flexibility are required. Mere achieving quality, delivery, and cost, QDC, is not good enough. So therefore, we need to also focus on the fourth weapon, as we call the flexibility. I'm sorry, I'm unable to share the slides due to the internet problem, but I'll try to forward these few slides to all of you. And before I hand over to Senthil, I'll just cover a couple of points. The journey of industrialization, or Industry 4.0, has gone through 1.0, 2.0, 3.0. And we all know 1.0 is about mechanization, 2.0 is about mass production through electrical motors and electrical energy, 3.0 is where the computers and automation advent happened, physical systems, Internet of Things, and cloud computing, and all these things are come into play. And each one of them have got history. The whole history started in 1784 with Industry 1.0, with the steam engine, and going on till 2020, now 24 now, with the latest lean Industry 4.0. So by amalgamating the lean principles with Industry 4.0, we get what is called the lean 4.0. And lean 4.0 is not just trying to merge the two concepts. It is trying to augment the lean concept through digital technology. We are trying to enhance the lean concept through digital technology. We are trying to modify the lean concept through digital technology, so that we can achieve the major principles of mass customization, variety, and fluctuation demand, etc. I mentioned. Then we have pandemic disruptions arising from COVID kind of thing. We have the Ukraine war, we have the Middle East war, etc. We got the VUCA world, volatile, uncertain, complex, and ambiguous world, as we call it. And beyond operational excellence, beyond lean, how to achieve operational excellence? Lean has achieved certain level of operational excellence. Lean has achieved certain level of overall equipment effectiveness. How do we go beyond the current level of lean and reach operational excellence, which lean could not achieve so far? And above all, how to create a visibility, end-to-end visibility. What is end-to-end visibility? From the design to the after-sales service. Design of a product, development of the prototypes, supply chain components, sourcing, making the initial lot of production, PPAPs, as we call in automotive industry. Then we are trying to make a mass production, and then sales and service. In the after-sales service, we have to ensure customer doesn't face any quality problems. And above all, the feedback mechanism. From the after-sales service, there is a feedback to the manufacturing subsystem. From the manufacturing subsystem, there is a feedback to the supply chain subsystem. From the supply chain and manufacturing system, there is a feedback to the design and development, R&D. So there is a PLM, as we call it, product life cycle management. End-to-end visibility is required. I don't think the conventional lean could achieve that. Now we come to the concept of a tracking and traceability through the lean 4.0. I think Senthil will talk more about it in today's session, as well as in the subsequent 6 sections, as we take up on a monthly basis, one by one, right? I don't want to take much time. We all familiar with the major aspects of Industry 4.0. I just want to summarize Industry 4.0 into 2 aspects. One is the flexible automation. Another is the intelligent automation. Flexible automation covers robos and cobos and PLCs, HMI, SCADA, and so on and so forth. Whereas intelligent automation includes Internet of Things, which are superimposed onto conventional automation. While automation was born even in Industry 3.0, the intelligent automation is alluding to the Industry 4.0. So basically, there are many players in the Industry 4.0 area in India, and Maxbyte Technology is a budding and a very successful startup, now headquartered in Abu Dhabi, and they are also having their original founding fathers in founding centers in Coimbatore.
Yeah, I think there's some disruption, sir's connection.
Okay. So shall I continue, sir?
Yeah, go ahead, please.
Okay. Thank you. We have with us the speaker for today, Mr. Senthil Prabhu, who is the Director, Lean and Industrial Data at Maxbyte. Mr. Senthil Prabhu has a decade of deep manufacturing domain experience in his different technical and management career roles in various industries. He has worked through success initiatives across the global regions and various customers for the adoption of digital robotics and for sustainability initiatives. Now the stage is yours. Over to you, Mr. Senthil Prabhu. Thank you.
Yeah, thank you, madam, and thanks, Mr. Chandramouli sir, for the brief introduction, and he has done almost half of my job. So, good morning to all. I'm
Sorry,
Senthil
my call dropped in between, and I wish Senthil Prabhu all the best. Carry on, sir. I will try to reconnect through the mobile phone or through my internet again. I mean, in the laptop. Thank you very much. Go ahead, Senthil.
Thank you, sir. Thank you, sir. So, I carry on experience of various corporates in different domains in production and operations management, operation excellence, and in lean. So I welcome you all to the first webinar series on smart and sustainable manufacturing solutions. So here we go on session with Lean 4.0 on how to achieve higher efficiency, flexibility, and competitiveness in the industrial environment. So to touch on the basis of Lean for people who are not aware, let me have a fast go through on the Lean's fundamentals of Lean. So Lean manufacturing is a production methodology aimed at waste reduction and efficiency improvement. It normally emphasizes continuous value delivery to customers. So it's basically originated from Toyota production system, which is called as the mother of lean manufacturing, wherein it's basically a concept driven by the car manufacturer to reduce the waste in this factory and reduce the space. So it normally focuses on eliminating non-value adding activities to streamline the operations. So basically the principles of lean manufacturing are 5. So we start with the defined value, means value is what the customer pays for. So we define values from the customer's perspective and provide what they want. So normally when a value stream, there are different type of process, what we call as SIPOC, supplier, input, process, output, and customer. So based on this SIPOC, the value across the process or product has been mapped, and we understand what is this value add and what is not value add. So whatever is value add, we align the value added steps based on the process flow continuously as the third step must make a value flow. And from normally a conventional method of push system, we would like to go for a pull system. So it allows the customers to have a pull value based on what we produce was what we've been ordered. Were you able to hear all my old discussions?
Yes, yes.
Okay. So what is waste? Waste is a value add. It can be divided into 3 things. One is basically a value add for which the customer pays, and essential non-value add for which the customer does not pay, but we have to do it for essential for the product to meet the quality requirements. So the essential non-value add activity has to be reduced, and non-value add the activities or the actions are for which the customer does not pay at all. So we have to focus on eliminating it.
Mr. Senthil Prabhu, sorry to disturb. Your presentation is not visible. I think it has stopped. You need to share the screen, I think.
No, already screen is shared.
And now it's visible. You can opt for the presentation mode.
Okay. It's clear now?
Yes.
Yes, sir.
Yes, it's clear. Please go ahead, sir.
Okay. So, getting into lean manufacturing framework, what we call as a TPS basically. So we start with the stability of it's a house of 5 is what we call as, which is basically based on 5 elements on stability, standardization, just-in-time, Jidoka, and involvement. So the base is called stability, on which the 3 major framework of Feijunka, standardized work, and Kaizen have been there. And on top of that, we have the just-in-time, continuous flow, tag time, pull system, and flexible force, supported by Jidoka and separate machine and man work, abnormal identification, Poka-yoke, and visual control, which involves the involvement of the people to achieve the goals of high quality, low cost, and shortest lead time. So, coming to an overview of Industry 4.0 technologies, as said by Mouli sir, the industrial revolution has gone through I 1.0 to I 3.0, which starts with Industrial Revolution of 1.0, which starts with the mechanization of manufacturing of steam and power, water power engines, which began in 1950s with the use of steam power and mechanization of production. The I 2.0 has come up with in the early 1900s, wherein with the discovery of electricity and assembly line production, Industry 2.0 was evolved. And Industry 3.0 has started in the early 1960s through partial automations using memorable PLCs and computers. And now we are in with Industry 4.0, wherein smart factory autonomous decisions making of our cyber physical systems using machine learning and big data analytics and interoperability between systems. Is now we are into I 4.0 era. Okay. And what is I 4.0 is? I 4.0 technologies revolutionize the automations, monitoring, analysis of supply chains through smart technology, integration of intelligent digital technologies into manufacturing and industrial process. I 4.0 integrates technologies like industrial IoT, artificial intelligence, big data, robotics, and automation. It facilitates smart manufacturing and development of intelligent factories across the globe. Primary goals are to boost productivity, enhance efficiency and flexibility, and support intelligent decision making and process and customization in manufacturing and supply chain process. So the benefits of I 4.0 on lean manufacturing is the increased flexibility through I 4.0 helps to cope with the rising complexity. Moreover, I 4.0 is promising to cope with fluctuating market demand, superior to a level production in lean management. The economic production of goods in a lot size of one is a way to enhance production economics beyond traditional economics of scale. That means we get into a single piece flow rather than a batch production or a mass production flow. So how do we integrate a lean with Industry 4.0 technologies? So here Industry 4.0 technologies revolutionize the automation, monitoring and analysis of supply chains through smart technology. And we have various domains of I 4.0 technologies on lean. The big data and AI analytics, horizontal and vertical integration, cloud computing, augmented reality, industrial Internet of Things, what we call as IIOT, additive manufacturing, autonomous robots, simulation and digital twins, and cybersecurity. So let's get into the basics of big data analytics. So what is big data and analytics? Okay. So when we connect the machines with digitally, so this the current by means of tagging and other end devices. So we have lots and lots of data collected on everyday basis. Okay, so with lot of data or what we call tons of data, we need to make a data-driven approach. For example, if a machine is connected to the digital IoT, we can monitor the machine's OEE through digital, basically with the machine spindle start and stop. Okay, which gives us the availability of the A part of the OEE part. So with the data-driven decision making, big data analytics process vast amounts of data to cover on the patterns and trends, allows for more informed decision making and continuous improvements. Okay, based on those aspects, we can do a root cause analysis, wherein analytical tools are crucial for performing deeper root cause analysis. This will identify and eliminate source of waste and inefficiencies. So what are the lean tools used in big data analytics? We use value stream mapping, document and knowledge sharing, batch processing versus stream processing, data cleaning and preparations, data collection optimizations, feedback loops, agile analytics, collaborative tools, automated reporting, performance monitoring, continuous improvement, and scalable data storage solutions. Okay, these are tools used in big data, and what benefits we get out of that are increased efficiency, improved data quality, and we are able to get faster making decisions, and it obviously reduces a lot of cost savings, enhanced collaborations, continuous improvement, scalability, greater agility, reduced bottlenecks, return higher ROA on data investments. And getting back to the horizontal and vertical integrations, okay, the focus is on connecting across systems across the supply chain between external partners. The vertical integration is connecting systems with the same organization between the production and business operations. For example, when you want to identify within the systems, within the company, how does a product flow across the company through the value stream. It's a vertical integration. And how does the supply chain from the customer, from the supplier to the customer passes through. It's called as horizontal integration. So we connect with all the customers and suppliers, and also within the factory, to make it more visible and flexible. So the scope is to expand across different companies or departments within the value chain. And the key technologies used are the IoT, cloud computing, blockchain, big data, AI, and analytics. The primary goal is to improve collaboration, efficiency, and data sharing across the value chain, so that the information is available across the team to take a decision strongly. And the data flow happens to excellent data flow between the different organizations or departments. So right now, cloud computing is the talk of the place everywhere. So we don't have separate servers or individual infrastructure developed at each plant. We all go for cloud computing based on because of the scalability and collaborations. So cloud-based solutions offer scalable storage and computing powerful lean operations. And cloud platforms integrate systems and data for holistic view and lean operations. So the in cloud computing, we used value stream mappings, continuous integration, continuous deployment, just-in-time provisioning, 5S, Kanban, OK, root cause analysis, TPM, which is called total productive maintenance, agile methodology and Scrum in cloud environments, cloud automation, Lean Six Sigma in cloud computing, and performance metrics and KPIs. And we have a lot of benefits out of Lean 4.0 in cloud computing as well, which are continuous improvement, innovation, flexibility in performance allocations, reduced environmental impact, enhanced customer experience, streamlined supply chain management, improved resource utilization, enhanced security and risk management, data-driven decision making, and streamlining and operations and process automations. And now we have the augmented reality and virtual reality, wherein people are given a device to have it on their as a goggle to understand how to a work instruction can be educated. It's like so you can see what is happening, and now all the people are getting into AR and VR for training the employees and simulating the production process in a virtual environment. So earlier in traditional manufacturing, we were having all the on-job training for people to learn and upskill them on their job. Right now, the days have gone. Now we have come with AR, which is called augmented reality, and virtual reality as VR. So wherein the people can see and do himself on how to handle the on-job training itself. So it also supports the real-time assistance of worker tasks with real-time instructions. So they have been the time taken for training period is reduced, and the people can be faster to the production. Okay. And we use AR, VR on standardized work, 5S, Kanban, TPM, visual management, OK, and simulation process optimization. And we also use them on value stream mapping, just-in-time, root cause analysis, continuous improvement, and cellular manufacturing. So getting into IoT, Internet of Things. So it supports on enhanced visibility and monitoring. So IoT devices offer real-time data on equipment performance. They provide insights in the production process. They help monitor supply chain activities, and this technology is also increasingly essential in today's professional environment. Real-time visibility identifies inefficiencies, predicts maintenance needs, and monitor key performance indicators. For example, if a machine has got into a breakdown today, now earlier there were a manual reporting system. The production fellow will report to will call a maintenance guy, and he will report to the maintenance, and the maintenance has to come and check for the issue odds on the machine. Now, what happens to the IoT is that the machines are connected digitally everywhere, and when the spindle stops or when the machine creates an alarm, automatically the maintenance team gets the pop-up, and the ticket is automatically raised saying that hey guys, see that the machine has got a problem and you just have to go and close this issue on top priority. And we can also fix an escalation matrix so that the machine is stopped for 30 minutes. So So that's within the control of the maintenance. And every 30 minutes once, this can be escalated to the hierarchy level of above the top management, so that the management also gets involved on the critical machines or bottleneck machines to ensure that the production is not stopped and immediate decisions have been taken. And that's how they reduce the inefficiency in the system. The downtimes have been attacked very strongly, and we see a very clear downtime reduction trend. And by the way, the KPIs also have been improving effectively. And also on the predictive maintenance part, IoT sensors can monitor machinery conditions and predict failures before they occur, reducing unplanned downtime and maintenance costs. And this happens really as a pattern way, wherein all the equipments or all the sub elements of the machines have been monitored and through artificial intelligence or through predictive analytics, so that we don't have a downtime or we don't react to after the machine has failed. So now we know that at 70 or 80%, 90% of the life of the equipment or sub element, we replace them in a planned way so that the downtimes are completely avoided and there's no much of delivery failures. So this is one of our dashboard which we have developed for one of our customer. So industrial IoT and lean process are combined in advanced analytics in data analytics methodology that uses predictive modeling, machine learning algorithms, deep learning, which involves business process automation, and other statistical methods to analyze business information from various data sources. So here we have the refrigerant dryer as one of the equipment which is being monitored, and we monitor them on operational efficiency and on the component health. So right now they are 100%, and we also have the data for the air temperature inlet and air temperature outlet, which is a continuous monitoring, and the people sitting across the dashboards understand the health of the machine and the operating parameters of the machines also. So we need not go there and check each and every machine's efficiency or performance there. So automatically our digital system ensures that all the parameters are monitored and the machine's health and efficiency is being maintained across the tables. So the advanced manufacturing technology involves additive manufacturing. Currently, the concepts of casting and machining are going out, and it's increasing with the 3D printing, wherein enabling rapid prototyping and customization, reducing lead times and waste. Metal waste have been reduced now. So what is what we say build to part. So flexible manufacturing system allows for quick changes in production process to adapt to different products or volumes, increasing responsive and reducing setup times. So these are the lean tools used in advanced manufacturing systems, and all have been made with 4.0, and we're also trying to bring in Six Sigma and Lean 4.0 as well. And right now, in I 4.0, we have also aligned with advanced robotics to bring in flexible automations, wherein collaborative robots and cobots advanced robotics handle repetitive or hazardous tasks with accuracy. This frees up manual human workers to focus on more value-added activities, increases overall productivity, and supports lean emphasis on maximizing values. And process standardization, what we call as ABOT. It basically works on the to ensure the consistent and standardized operations. This reduces the variability and improves the process reliability. These are various lean tools used in advanced robotics as well. So this is one of the I 4.0 technologies called as robotic process automation, where automating the repetitive and manual tasks reduces human error, sets up speeds of the process, and frees up employees to focus on the more valuable activities. And we often use collaborative robots to work along with the humans to work on handle tasks that are economically challenging or require precision. So it's a semi-automatic or working collaborative robots, which works aside by the humans and supports them in working on a challenging environment, improving both safety and productivity. And right now we bring out with digital twins, the concept of creating virtual replicas of physical assets or a process based on real-time monitoring. This enables real-time monitoring and simulations, facilitates better understanding and automation of production process. And normally the scenarios testing digital twins are used to predict impacts, reduce risk, and improve decision making before pre-implementation set at all. So it's one of the digital twin implemented in one of our customer place, wherein you can see the movement of the material, and you can also understand the OE or real OE of the machines at the real time. So it clearly indicates what metals are on the line and what could be there to make a stoppage, and what is the real OE at the plant level. The benefits of Industry 4.0 OS on the manufacturing background is reduced maintenance planning down by 20 to 50%, diminished maintenance, total maintenance cost by 5 to 10%, increased equipment uptime and availability by 10 to 20%. So we have a lot of application there. We are into automotive, production and inventory management. We also into aerospace and engine overhaul and spare parts management. We are into process industry on metals management and assets management. And we have a lot of common issues, which is supports on throughput time, equipment downtime, rework and reinspection and inventory cost. And in the aerospace industry, we have turnaround time and obsolescence cost. And on a process, we have metal wastage and equipment availability, which we have provided solutions with one-piece flow and full system, improving the equipment reliability and elimination of defects and inventory optimizations. And also on the process streamlining, standard operating procedures and spare parts management. And on process, we have supported with the elimination of defects and reduce of unplanned downtime. So we have a few of the companies whom we are working with the implement of lean concepts. In Toyota, in Bangalore, we have supported the Toyota on implementing the 4.0 with big data analytics in manufacturing facilities. And we have utilized the real-time data from connected machines, allowing monitoring of equipment health and worker efficiency. And this support us in meeting increasing demand of customers, high quality vehicles while uploading the company's efficiency and cost effectiveness. So these are the connections what we've done. IoT sensors have been installed on all machines and production lines, monitor performance metrics such as efficiency, quality, and productivity. Real-time data is transmitted to Senthil's cloud platform for analysis and decision making. And with big data analysis, the analyze data to identify patterns and optimize machine scheduling. Predicted potential failures, enhancing operational efficiencies, lead to streamlined operations and reduce waste through improved forecasting and scheduling. And we use robotics to improve the decrease the manual labor, and it also supported in improving the precision in task, and it has resulted in improved quality, consistency, and reduced defects. And the results what we have achieved is achieved 20% reduction in lead time by improving workflows and utilizing real-time data to manage production, and supports an enhanced machine uptime to predictive maintenance, reducing the unplanned downtime by 20%. Enable more optimized customized production through flexible management systems, allowing Toyota to meet challenging customer needs more efficiently. And we have also supported Bosch. Bosch was encountering difficulties in overseeing production process in its global manufacturing plants. And because of rise in customer demand and a complex supply chain, prompted Bosch to improve its operations. And this enhanced operations was crucial for Bosch to stay competitive and uphold high quality standards. And with Lean 4.0 implementation, Bosch was able to get all the machines with IIOT and they utilize the machine learning algorithms and cloud-based analytics to enhance manufacturing process. And we also incorporated augmented reality in the quality control and assembly. So here also Bosch deploy IoT sensors to monitor equipment performance, track inventory levels, and monitor the entire manufacturing process in real time. And they supported with the artificial intelligence-based machine learning. The data from machines were utilized to train machine learning models. Models predicted failures and optimized their production schedules, ensured high quality output by adjusting parameters in the manufacturing process. And they also integrated all the data into cloud analytics, wherein Bosch implemented cloud-based analytics to consolidate data from various locations. It's called as enterprise level planning, wherein all the different plans data have been combined and has been collectively analyzed to have better performance. This allowed for monitoring of machine and production line performance. The approach enhanced efficiency tracking and pinpointed improvement opportunities within the facilities. And they also have gone with augmented reality. AR glasses enhance assembly work by providing real-time visualization of assembly instructions and quality standards. This technology ensures precise adherence to work steps, significantly reducing the likelihood of defects and also on the safety front. And one of our GE aerospace and defense industry, GE encountered difficulties in aircraft maintenance engine manufacturing facilities. And the key challenge was to decrease production time for intricate components. And the company aimed to enhance production process accuracy while managing costs effectively. So they implemented a 3D printing for rapid prototyping, and the IoT sensors were utilized for real-time monitoring and predictive analytics, what we call as ADAM, were employed to enhance product optimizations. So these are the key points which has been used by GE for the 3D printing and IoT sensors and predictive analytics. And right now they have also integrated their robots into their automotive repetitive task, wherein this decreases the human error and increases output to the improved consistent quality. Overall, these achievements and advancements contribute positively to sustain the I 4.0 in this plant. Any questions?
There is one question, which are best application platform for manufacturing industry to be used for the app development?
See, one of the application could be our OE. See, right now what happens in major of the manufacturing industry is that they go with the manual way of calculating OE through Excels, which can be interpreted or which can have a variability which is not actually in the shop floor. So once you connect all the machines through IoT devices, and there's no need for any manual interpretation or intervention to calculate this. So whatever comes on the machines are live and at real time. They can be very clearly be monitored across the plant, and we know what is the real time OEO as well. And we'll not wait up to 24 hours next to understand what the machine has gone wrong and why it has gone wrong. So we can take actions immediately to reduce the downtimes and improve the operational flexibilities. And that's number one. And number two is that we also have the condition monitoring of the equipments to ensure that we don't have a downtime on the premature failure or the failure of the equipments. So wherein we monitor the lifetime and take a very calculative decision on replacement of them without causing any downtime on the equipments.
I have enabled the audio for the participants. I would request the participants to kindly ask any question to the speaker, or you can even drop in your query in the chat box. Mr. Senthil, there is one more question. What improvement is needed in software integration to achieve lean manufacturing?
See, in software, okay, again, you can identify what are all the ways that you are undergoing or what you're adapting yourself. So from customer perspective, the only question you could ask is the customer paying me for the operations what I do? And if the customer doesn't pay for what I'm doing, and that has to be eliminated. And there could be something called essential non-value add, for which the customer does not pay you, but still you need to do it. So that need to be understood by the management and by the person who's doing it, and that you have to reduce it. You can't eliminate it, but you can reduce it.
One more question is, how is it applicable for low volume OEM manufacturers, the lean management?
See, for low volume, you can go for a single piece flow. That's what it says. But depending upon the customer need, you have to plan accordingly to make a single piece flow or a batch size of small batch size. Preferably based on a pull system, not a push system. Based on the customer need, you need to make a production based on the pull. What is required for the customer?
I may also add here, Senthil, am I voice
Yes,
audible?
yes, sir.
See, there are two ways of looking. One is low volume versus high volume. Is a question of production demand only. But the lean concepts of waste elimination applies. Whether you are making a project-based manufacturing, for example, when you are manufacturing, let's say one large, let's say aircraft, one large aircraft is a low volume production, right? But even in the production of the aircraft, there are many lean principles can be applied, particularly the waste elimination principles, the 8 principles. Yeah, whether it is overproduction, over processing, excess motion, excess inventory, all this applies, and more defects. Defect is a ubiquitous. Defect is there everywhere, right? Regardless of low volume, high volume. So lean principles are not dependent on the volume of production. In fact, if the low volume is there, we can easily implement the digital concepts easily also, because you can bring in the IoT system and sensors can pick up and measure various problems as Senthil has described in a low volume production, right? So I think both lean and lean 4.0 do not really depend on the vast volume of production. I don't know whether it answers the question.
There is one more question. To conduct a value stream mapping, how should the industry select the process or parts? What criteria should the industry use to choose the right part?
Dr. Senthil can answer this.
Yeah, it will be mostly based on your critical process or your critical bottleneck machines, or the product which is fast moving, which is bed winning, where you need to reduce your lead time or your process time on that.
In other words, to elaborate what Dr. Senthil mentioned, can I?
Yes, sir.
Wherever the customer challenges are intense in terms of lead time, because the primary objective of value stream mapping is lead time reduction. As I mentioned in the beginning introduction, if response ratio 144 can be brought down to response ratio 1, namely the total throughput time of start to finish of a product divided by the cycle time of producing any one piece is called the response ratio. If this response ratio can be brought to 1:1, that's an ideal situation which nobody could achieve in this world. There are case studies where people have come as close as possible to 3:1. But if something is at 144:1, there's a huge potential to reduce that. So lead time reduction is a primary objective of value stream mapping. And as Senthil rightly pointed out, start with the bottleneck operation. But once you resolve one bottleneck, another bottleneck will surface. It's like the Titanic ship and the iceberg concept. The moment one iceberg is exposed by the sea level coming down, then another iceberg will come down. So on and so forth. So as we expose the problems and one by one the bottleneck operations, we have to address the bottleneck operation through lean technologies and preferably lean 4.0, because the concept of industry 4.0 will quickly on a real-time basis expose the problem. It is not a passive approach, but an active approach, because the real-time basis means the latency between data and action is minimized. Between input and action is minimized in the industry 4.0 context. Am I right, Senthil?
Yes.
So the primary advantage of anything in value stream mapping of using industry 4.0 technique, right? They call it VSM 4.0. There is a big school of body of knowledge called VSM 4.0. Maybe another day, Dr. Senthil can do a research on that and present VSM 4.0. In the coming series, there may be many explosion of these topics, right? So in that, what they do, they look at how to deploy the various Industry 4.0 technologies, but to reduce the lead time of individual operations as well as a complete line of operations.
And
the focus is always throughput time reduction. Yes, sir. Go ahead.
Yeah, and adding to Sir's point, when you do a value stream mapping over a process from a supplier to your customer, and you identify the inventory time and all the things that the product passes through, obviously it's 99.6%, 99.7% is all non-value activity only. So there's a big scope for improvement, wherein 99.9%, 99, even for 99.7% of the time, the copper is literally idle, and a lot of time is wasted there.
Absolutely. So that is an extreme situation of lead time reduction potential. But the throughput time, vis-a-vis the cycle time, is a challenge that most industries are facing, and very little effort has put in reducing the throughput time in many industries. Not only automotive industry, in many industries. That could be a low volume production, that could be a high volume production, that could be a single model concepts, it could be multiple model concepts. But throughput time reduction is a primary goal of just-in-time concept. And also it can be enhanced and augmented using digital technologies. In fact, Maxbyte has already done these projects in Toyota, Bosch, GE, all this presented. Those are real-life case studies of Maxbyte. So they can engage with most of you and demonstrate in your respective companies and factories. I think one Mr. Anil had some questions. Go ahead, sir.
Yeah, good afternoon, sir. I just wanted to know your thoughts regarding usage of machine vision, that to AI-driven machine vision solution within Lean 4.0, how to use computer vision techniques.
Over to Senthil, Prabhu. Mr. Anil, you're from which company?
Sir, I am from a company called Smart Track AI.
Very good. Okay, Mr. Senthil, you can address Anil's question.
Mr. Anil, on the machine vision system, currently we have used cameras to inspect the product quality, and we have implemented a line, an automatic line in an automotive industry, wherein the component has been passed automatically without any manual intervention in the quality. The camera senses the part, measures the dimension of the part, and certifies it based on that. So the quality part of the product has been taken care by the machine vision system now. We have a case studies on that.
Yeah, I agree, sir. May I know the percentage accuracy achieved with this solution and the F1 score, because these two are very important performance.
Yeah, Mr. Anil, this has been in the trial for last 3 months in our customer place, and we achieve 100% quality and reliability on the machine vision system, and whatever they have approved based on this machine were perfectly okay. We had a SPOC based on that and POC based on that, and after 3 months of trial, it is now implemented in the lines.
Okay, sounds great. And
are this,
second,
Dr. Senthil, are these in assembly line?
Yes, sir. Assembly output line, sir.
In fact, Mr. Anil, I have seen in TVS Motor, Dr. Devarajan took us there, our past president, that vision-based assembly management, foolproofing, Pocoyoke, using camera and operator empowerment through vision-based system in both quality of the assembly line quality, stage quality, and in pick and place components in the assembly line. These are all the fantastic examples we saw in TVS Motor. There is another interesting case study going on in the market. Maybe another day I will share with you. Is a two-handed vision-based camera system. It has been patented by a company where there is a special camera and 2 cobos. The 2 cobos are aligned with the camera. And this has become very popular in the FMCG industry, where especially for the quality control in the line, where the two combos work typically almost like a human hands. And the camera is a special camera, work like exactly like a human eye. And these are all the interesting examples coming up in the industry. Go ahead, sir.
And we have also made a lean COE with the gearbox industry, inspecting the gearbox through cobots and machine vision system. When the machine vision system gives a clearance for the cobot picks the component from the conveyor and puts in the trays for packing.
Fantastic. Is it in Hansen Suzlon?
No, sir. It's a part of lean COE for Maxbyte at Saudi, sir.
Oh, it's in Middle East. It's a case study in Middle East.
Yeah.
Very good, very good, very good. It's in gearbox manufacturing, is it?
Small gearbox manufacturer, sir.
Very good. You can forward the case study to us and we can share with our members. Thank you.
Sure, sir. Sure.
A short 1 slide, 2 slides kind of thing.
Of course.
Yeah, the
If
second part.
possible, a video will help. A video will help to understand these things.
Sure, sir.
Any other question, Rupa?
Yes, sir. Yes, sir. The second question is regarding use of AI-driven co-pilots in manufacturing assembly lines. Any case study you have for AI co-pilots which can assist the operators without use of SOP? You can call it as a digital SOP, so that at each and every step he is being monitored, and if he tries to do something which is not as per the standard, then the red flag is there and the process stops, thereby ensuring there is no fault during the assembly. It's basically a digital POCA use of AI co-pilot.
See, exactly we don't have a POC of that, exactly what you're saying for, but we have a similar one wherein as I said, in our COE at Saja, we have installed a cobot which does the inspection by itself with a digital SOP, and it holds the gearbox at one stage. It turns at different stages to the machine vision system one by one, and it certifies and qualifies the gearbox based on the SOP what you have dictated to it through artificial intelligence.
Okay.
So the final stage of the conveying system doesn't have a human at all. It's a cobot which you have taught it through artificial intelligence to understand the process of operations it has to undergo, by which the machine vision system is at only one place, and we have 6 sides of the gearbox. So all the aesthetic, the appearance, and the other significant dimensional characteristics have been taken up by the cobot, and based on the approval from the machine vision system, if this cobot certifies this part is okay or not, accepted or not. That's what we implemented, but we have not implemented across all the other lines of there, and we didn't have such a POC yet.
Okay. The other thing is regarding my company.
Mr. Anil, can if you don't mind, can you just spread the questions to more people?
Okay.
We can come back to you, but let us find out if others have any questions. Then we come back to you. Not an issue. I mean, we encourage one-on-one also. Later on, Senthil, Prabhu, and Anil can have a direct dialogue. Anil, you can text your phone number and email ID in this text box, and Rupa can forward it to Senthil, Prabhu for a direct dialogue and detailed interaction. I'm just trying to spread this so that we get multiple perspectives of various people. I have one question, Senthil, just to trigger a thought. Have you implemented Kanban 4.0, where the pull system, you mentioned pull system many times, and can you illustrate the Kanban 4.0 concept? Have you implemented in India or elsewhere?
Sir, Kanban 4.0 we have not implemented, sir.
What I'm trying to say, how to enable the pull system through the RFID mechanism which is the initial dialogue you had with some of the companies. So any such implementation, POC or any implementation you
Sir,
can think of?
we are in discussion with a customer of HVAC for this, wherein the customer demand is based on the marketing wing, and the pull system is based on the actually all the inventories or all the movement of metals are to the line based on the triggering through RFID, sir. That POC is
Yes.
right now with one of a customer called Blue Star, and it's on the POC, sir.
Very good, very good. I'm sure your Bosch also, the example of Bosch, what you mentioned, must be Kanban driven, I think. Maybe you're not calling it Kanban, but it's a withdrawal pull system. Yeah, replenishment based pull system, I think you've done in Bosch, correct?
Yes, sir.
Is it a Bosch India or is it Bosch somewhere elsewhere?
Bosch Bangalore, sir.
Oh, very good. Okay. Okay, Mr. Dr. Narahari is appreciated. Dr. Narahari, you have any question on the academic front, sir? Hello?
Yeah, excellent session. Thank you, Senthil sir. My only question is, why are SMEs hesitant to implement this in India?
Good question. Go ahead, Mr. Senthil.
Sir, two things. What I could say, the technology or the knowledge of the people in I 4.0 is still not yet reached. Number one. Number two is that the reliability on the investment part are the two parts which could be still the SMEs are thinking about it. Over to you, sir. Anything on that?
Well, I can add a value to this question. In some of my dialogues with MSMEs, the first point arises is they think it's more of a technology driven approach. We have to convert it into benefit driven approach. The business value proposition of how a quality improvement, productivity improvement, reliability improvement, safety improvement, and so on and so forth are addressed rather than confuse them with IIOT and other jargons. Right? So first we have to address the current status of quality delivery, cost, etc. problems, right? Measure it, and within its very short period, we show them a demonstration that it is possible to improve those business deliverables. And if you're able to convert each one of the deliverables into monetary benefits, the second aspect for MSME, they want to know what is in it for me, number one. Number two, how to convert it into monetizing. Quality improvement, for example, cost of quality. The defects which have happened so far cost 1 crore. But with the digital technology, it became 40 lakhs. So there is saving of 60 lakhs. I'm just giving an illustration. And the other big subject, Dr. Narahari, is a variety management. I visited, this is a famous case study I talk in many of my forums. I went to a Chennai company, Indo-Korean joint venture, and I found that they're producing clutches and brakes for the tractor industry. I asked them how many types of tractors you are addressing and how many clutches and brakes are making. They said they make 200 SKUs. 200 SKUs means each is a different design of clutch and brake for a different type of model of tractor across the country, and some of them are also for foreign market export and all. They specialize only in this, making this variety of trucks and clutches and brakes only for tractor industry. And then I asked them, what is your biggest challenge in the production system? He said, sir, we have to achieve 50 ppm, 50 parts per million. That means almost zero defect. However, there is a lot of mix up and mess up in the shop floor. They were so frank. I said, what is mix up and mess up? They took me to shop floor and showed the child parts, the springs and washers, so many other, the brakes and discs and whatnot, the child parts are getting mixed up. This is an MSME company. It's only 200 crore company. The current definition of MSME, 200 crore is a medium size company. It may not be small in that definition, but at least yum is a medium. Micro, small and medium. Yeah, MSME, E is enterprise. So the medium size company, 200 crore. They have target to reach 500 crores. They said unless and until they resolve this mix up and mess up. So in that case study, we gave a proposal for minimizing the mix up and mess up using Industry 4.0 technology, particularly RFID, traceability, track and trace, etc., etc. So there are powerful methods I have seen in a company, Siemens Kalwa, how the RFID technology plays a strong role in managing 150 types of production of MCB, switchgear, miniature circuit breakers. 150 different models are produced in a single line, and it is supplied by Titan Automation. Titan Automation has supplied a single line with RFID and other technologies, where each station has got a RFID enabled bucket. In the bucket, there is small bucket, small tray kind of thing. Inside, there is a memory which is stored, which covers the bill of material of the product, the child parts, the process bill of material, which means the routing. Everything is stored in that, including quality specification, quality requirement standards. Everything is in the RFID chip. That is in the tray, in that bin, and it can be written again. It's not that you have written only one particular requirement. It can be rewritten. You can erase the previous data and you can read it. And then all these trays are going in that assembly line. Mixture of models, 150 models of MCB are going through. I went there 4 years back now, or maybe 5 years back. So they could reduce the lead time. They can eliminate defects. Fantastic project. Titan Automation together with Industry 4.0. They supplied in Siemens. Siemens itself is a Industry 4.0 global leader, but they could get it done through an Indian player called Titan Automation. So this is an example where variety of parts when you're addressing in MSME. See, OEMs produce only a couple of models. The large companies, Tata, Toyota, but their sub-suppliers are making many parts because they are supplying to multiple OEMs. So it is wrong to assume that mass production of OEM requires Industry 4.0, whereas MSMEs do not require Industry 4.0. It is the other way around. MSMEs have got more variety of parts. So they require Industry 4.0.
Complexity is more in MSME.
Complexity, variety, traceability is much more. Thank you, sir.
So was it insight to development? Insight to development, or I am curious to know, the Titan Automation, did they do insight to development there, or they developed the module elsewhere and installed in the assembly line?
It's a joint development with customer. In all these projects, there is the DAP, or what is called design approval process, is there, where customer will engage with the supplier for 6 to 9 months in designing what they require. Nothing is standard solutions.
Okay.
Every project of Titan Automation is customized for a typical customer.
Okay, sir. Thank you.
Thank you, Dr. Narayari. In fact, Dr. K. N. Subramania wants to give a presentation on Lean 4.0 modeling, academic modeling. And we are looking forward to it in the couple of, in these coming months, coming weeks.
Okay, sir.
That will be a very interesting session because most of us is still in the research base. When I myself studying this topic, I found that at least 100 research papers are there on the topic of Lean 4.0. Mr. Anil has still some questions. Mr. Anil, go ahead, sir. Mr. Anil?
Yeah, I don't have any questions, sir.
Your hand was raised. Okay. Any other question from anybody else? Okay, Dr. Senthil, I have one question. With so many projects you are doing in Lean 4.0, have you developed a ROI, return on investment model? If so,
sir, we have developed ROI for one of our customer, and over a 5-year period of time for the digital product, what it normally varies with different products or different applications what we go with. And with Lean 4.0, with one of our customers, we are able to get around 28 to 29% of ROI, sir.
No, I'm not talking about your achievement. I'm talking about modeling. See, return on investment modeling for Industry 4.0 is a very important topic for convincing the customer that if I put in 1 crore investment, I'll get a 2 crore benefit within 1 year. The payback period should be 6 months. So I'm just asking whether your company has made any model, how to arrive at ROI model. So this is a very interesting question. Many people ask me, sir, how to calculate ROI? I'm not talking about typical ROI achieved by you. I'm talking about modeling of the ROI.
Sir, we have defined and delivered a model based on the module that you're selecting, sir. For example, if it's a OE module, what is the ROI? If you use a condition-based condition monitoring module, what is the ROI? So based on the different application that you're going with, or AI 4.0
Exactly.
model going with, you have developed a model. And what I'm talking about is on the OE module, we were able to get over a period of time of 5 years, ROI of it again varies. It again starts with 10 to 12%, and over average it's around 28%, sir. So I made it model for OE, sir.
Fair enough, fair enough. You are again illustrating the achievement made, but I'm more interested in modeling, which may or may not talk about the typical achievement. So what we'll do, I'll talk to you offline. So we may have to have one session in the next 6 months or so,
Okay,
which
sir.
is clearly focusing on return on investment modeling. And it is a subject which is very important for the industry to really adopt or adapt 4.0 and other technologies in a faster pace. If you are able to demonstrate that, I'm not talking about physical demonstration, I'm talking about mathematical modeling or the financial modeling. Let me put it as financial modeling. The financial modeling of ROI for Industry 4.0 is more an academic or a management subject as well as an industry subject. So talk to Ram Shankar and other top management of your company that this could be an exclusive 45-minute session, and could be a brainstorming session also, where you come down to Bangalore along with Gift Selvin and others, where we can have a ROI as a separate brainstorming session, and BCIC can facilitate that.
Sure, sir.
Because many people, the delay in implementation or the skepticism in implementation is how to convert the financial benefit. If you can't do the financial benefit of the quality, delivery, cost, lead time, etc., then not only MSME, even larger companies are not motivated. There are 5,000 large companies, 50,000 medium-sized company, and at least 5 lakh small companies in this country. So there's an enormous potential. But because other countries are appreciating it more, like Saudi Arabia and others, Indian software and IT industry, IoT industry is rushing to get the business from other parts of the country, world, rather than the huge, humongous potential that India offers. We have to break the ice by creating an ROI modeling. That's my request to Senthil Prabhu.
Sure, sir. We'll work on it.
Okay, ladies and gentlemen, I think there are a lot of more questions coming up. They can mail to Rupa, and then Rupa can disseminate to the forum. Rupa, in these 6 months, Rupa, are you there?
Yes, sir.
In these 6 months, try to create a community of all those registered participants and those who could physically come in or could not come in, but all those registered or the interested people. Try to compile them and create a forum whereby you keep on creating the forum. And we can call it the BCIC 4.0 community. It is not a committee, it is a community. And then we can exchange various thoughts and so many things which are very generic in nature to this particular adaptation issue, and not particularly specific issue to any one customer or a technology leader, but generic issues like we keep debating can all be posted in the community, and people like Senthil Prabhu and Anil and Dr. Narayari, all of them can contribute to such community work. Am I right? Rupa, can you do that?
Yes, sir.
We'll call it as the Industry 4.0 Community Forum of BCIC.
Yes, sir.
And it can have members and non-members, everybody coming into the community. Not an issue. Over a period, they see the benefit also. Thank you. On that note, I will thank all the participants. I think there are still 30 people on the call. And sorry, my internet failed, and I will share those 10 slides. Rupa can send it to all the registered people. And Senthil Prabhu, if it is okay, you can convert your presentation into PDF, and then Rupa can circulate to all this one. And this is also going to come into the YouTube. With all the interruptions we had, it will still be on YouTube. That will get disseminated through LinkedIn and other forums for the benefit of the entire industry. And this is a mission of BCIC Industry 4.0 Committee. Thank you very much, Rupa. Thank you very much,
Thank you, sir.
Senthil is a doctor actually. Yeah, Senthil Prabhu, you are a doctor, correct?
I am pursuing doctorate, sir.
Pursuing doctorate. He is trying to do a doctorate in lean. He was a manufacturing manager of one of the major windmill gearbox company. Senthil, am I right? Suzlon.
Yeah, sir. Perfect. ZF.
Hanson Suzlon, which later became the German major. ZF. Thank you, Dr. Senthil. Thank you very much for participating. We look forward to the coming up seminars, or the dates are not been fixed. For all those who came to this and the future people, please multiply the communication so that we can have a larger participation. Our target for next month presentation should be at least 100 people, and then thereafter 200. It should come multiply in arithmetic and geometric progression. Thank you, Ms. Rupa. Thank you very much. Bye-bye.
Thank you very much. Thank you all.
Thank
All
you,
the
sir.
best.
Thank
Thank
you, Mr. Senthil Prabhu, and all the participants. Thank you.
Thank you, Rupa, for your coordination. Thank you.
Bye-bye.
Thank you.